Today we're going to take a look at double angle identities. Double angle identities are going to be derived from sum identities. So remember last time we had two sum identities. We had the sum identity for sine. It says sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. We also had the sum identity for cosine, which says cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And now let's derive our double angle identities. So for our first one, let's start with sine. So our double angle identity is going to look like sine of 2 alpha. That's why we call it a double angle identity, because our input here is double alpha. And first thing I'm going to do is I'm going to break up this 2 alpha here. Sine of 2 alpha is equivalent to sine of alpha plus alpha. And now we can use our sum identity for sine. Right? Notice instead of an alpha plus beta, what we have is an alpha plus alpha. So when I plug into the right-hand side of my identity, what we'll have is sine alpha, cosine alpha, plus cosine alpha, sine alpha. And now notice these two terms are identical. I mean, the order is switched, sine alpha and cosine alpha, but since we're multiplying, the order doesn't matter. We're going to end up with 2 of them, and what we'll have is 2 times sine alpha cosine alpha. And there it is. This is our first double angle identity. It says that sine of 2 alpha, that's the expression we started with, is equal to 2 times sine alpha cosine alpha. That's the expression we ended with. Now let's take a look at our double angle identity for cosine. So cosine of 2 alpha, and we're going to use the same trick as above. This is the same as cosine of alpha plus alpha. And now let's use our sum identity for cosine, right? Again, instead of an alpha plus beta, we have an alpha plus alpha. So using the right-hand side of our identity up here, what we'll have is cosine of alpha minus sine alpha, sine alpha. And when we simplify, well, cosine alpha times cosine alpha, that's cosine squared alpha. And then minus sine alpha times sine alpha is sine squared alpha. And there we go. This is our number 2 identity. The double angle identity for cosine says cosine of 2 alpha is equal to cosine squared alpha minus sine squared alpha. Now there's actually 2 other forms for the double angle identity for cosine, and I'm just going to write down what they are. I'm not going to derive them, although deriving them is not difficult. All you have to do is use the Pythagorean identities. But I'm just going to write down what they are, and then we'll move on to some examples. So our other 2 forms for cosine of 2 alpha look like this. So the first one says cosine of 2 alpha. That's equivalent to 1 minus 2 sine squared alpha. And the other one says that cosine of 2 alpha is equal to 2 cosine squared alpha minus 1. So if we're doing a double angle identity for cosine, we can actually use any of these forms. So let's take a look at an example. Example 1. Let's use a double angle identity to find the exact value of cosine of 2 alpha. And we're given that sine of alpha is equal to 1/4. Okay, so our job here is to find the exact value of cosine of 2 alpha. So let's start by writing down the identity for cosine of 2 alpha. So cosine of 2 alpha, and notice what we're given here is the value of sine alpha. So let's look at our double angle identities again. And so for cosine of 2 alpha, remember we have 3 forms to choose from. Now we could maybe choose this first form, but notice we would need to know what sine alpha and what cosine alpha is. We were given sine alpha, but not cosine alpha. Now we could go and find cosine alpha, but that would just be another step that we'd have to do. What if we were to use this second form of our double angle identity for cosine? In this case, all we need to know is what sine alpha is, and that was given to us. So I think this is the form that we want to use for this problem. All right, so cosine of 2 alpha is equal to 1 minus 2 sine squared alpha. So cosine of 2 alpha is equal to 1 minus 2 sine squared alpha. That's the identity that we'll use. And now let's plug in what we're given. We'll have 1 minus 2 times sine squared alpha. And sine of alpha is 1/4. So what we'll have is 1/4, and then of course it's being squared because it's sine squared alpha. And if we simplify, we'll have 1 minus 2 times 1/4 squared is 1/16. So this becomes 1 minus 2/16, which is 1 minus 1/8, which gives us 7/8. And there we go. That's our exact value. Let's look at another example. Let's use a double angle identity to find the exact value of sine of 2 alpha. And we're given that cosine of alpha is 3/5, and also that alpha is in the 4th quadrant. So since we're trying to find the exact value of sine of 2 alpha, let's start by just writing down that identity. So let's go back to our identities. Sine of 2 alpha, and we only have one identity for this guy, so we have to use this one. Sine of 2 alpha is equal to 2 sine alpha cosine alpha. So 2 sine alpha cosine alpha. And let's plug in what we are given. We were given what cosine alpha is. So we have 2 times sine alpha. We don't know what that is, but we do know that cosine alpha is 3/5. Now notice I didn't write cosine of 3/5. Rather, this entire thing, cosine of alpha, that's what's equal to 3/5. All right. Now to finish this problem, well, we have to find sine alpha. So let's do that down here. So find sine alpha. And remember, alpha is in the 4th quadrant. So I'm going to go ahead and draw that in the 4th quadrant. So here's my angle alpha. And what we're given in the problem is that cosine of alpha is equal to 3/5. So that means that my hypotenuse is 5 and my adjacent side is 3. And in order to find sine alpha, we need to find this opposite side. Let's call it y. And notice since we're in the 4th quadrant, that means that this y value is going to be negative, and sine of alpha should be negative. Okay, so we'll keep that in mind. Let's go ahead and find y. So if we use our Pythagorean theorem, we'll have 3 squared plus y squared. That's going to be equal to our hypotenuse squared, so 5 squared. So 9 plus y squared is equal to 25. I'll get y squared is equal to 25 minus 9 is 16. So y is equal to plus or minus the square root of 16, which is plus or minus 4. But again, we know since we're in the 4th quadrant, this y value should be negative. So what we'll get for sine of alpha is -4, and then of course over the hypotenuse, 5. Cool, so now we can go ahead and plug that into our expression up here and finish the problem. So we'll have 2 times sine of alpha, which is -4/5, times 3/5. And now when we multiply, and notice this 2 in front, that's really like a 2/1. So when we multiply, that 2 just goes in the numerator. So 2 times -4 times 3, that'll give us -24 in the numerator. And in the denominator, 1 times 5 is 25. And there we go. That's our exact value of sine of 2 alpha.